Hello, good evening. Am I audible to you all? Hello, am I audible? Can anybody please confirm?
Yes, ma'am, you are audible.
Yeah, okay, thank you so much. So, good evening, everyone. I am Sandra Krishnan. I'll be your TA for this tutorial sessions on fundamentals of electronic materials and devices. So I'll present my screen now, and in case you have any queries, first I'll go through what we will be doing during these sessions, and in case you have any queries, please do ask me. So the idea is that we'll solve certain questions based on your assignments, and this will help you in your final exam as well as in submitting your weekly assignment. So that is the idea. So I hope you all are fine, and in case you have any queries, feedback, etc., you can reach out to me later as well. So, so is my screen visible to all of you? Hello, is the screen visible?
Yes, ma'am.
Yeah. Okay. So this is our first session on the course NOC24-mm10, that is Fundamentals of Electronic Materials and Devices. So this course is taken by Professors Parshuram and Swaminathan, who's a professor at Indian Institute of Technology, Madras, in the Department of Metallurgical and Materials Engineering. So, talking about me, I am your course TA. I am Samitra Krishnan P, a research scholar at IIT Madras, and I am a PMR fellow. So, every week I have to take live sessions on either NPTEL courses or other courses at other colleges as part of my PMR tenure. So this is my mail ID. So everybody please note down in case you have any doubts or queries later, you can reach out to me in this particular mail ID, that is santra.pmrf@gmail.com. So please do note down this email ID. You can also ask queries in case you're planning to pursue research at IIT Madras or any other institute. I'll be able to help you in whatever ways, that is to best of my knowledge. So please do note down this email ID. Yeah, I hope you have all noted down. Yeah. So this is the course details. So as I mentioned, the course instructor is Professor Parshuraman Swaminathan at the Department of Metallurgical and Materials Engineering at IIT Madras, and this is your overall course plan. That is in the first week. Like now, as of now, week 1 and week 2 lectures have been uploaded. So in week 1, we have introduction energy bands and solid semiconductor band gap formation. In week 2, we'll be having a problem set on week 1 as well as intrinsic semiconductors. Week 3 is extrinsic semiconductors, Fermi level variations, and conductivity. Week 4, we'll move on with problem set of week 3, that is extrinsic semiconductors and so on, followed by metal semiconductor junction and introduction to PN junction. Week 5, we'll focus on PN junction under bias, junction breakdown, as well as heterojunctions, followed by problem sets on week 4 and week 5. As we move on to the later part, we'll be focusing on devices, that is transistors, type of transistors, MOSFETs, problem set on week 6, etc. And in week 7, we'll be focusing on optoelectronic devices, their introduction, as well as LEDs and lasers. And finally, in week 8, we'll conclude with photodetectors and solar cells and the problem set on optoelectronic devices as well as from week 7 and week 8. And sorry, this is not Tuesday. On every Monday, we have our sessions from 7 p.m. to 9 p.m. So please do join for the tutorial sessions and it will help you in your final assignments as well as for your submissions. So what we plan to do is that we know that NPTEL sessions you all will be going through multiples of videos. We don't have any live interaction process. So in order to make your program more engaging, we'll be having a live interaction session, and the session, each session will be for 2 hours. The idea is that during these sessions we'll practice assignments. One thing, I'll make a set of questions that is similar to your assignment and we will solve these assignments. Another thing we can do is that doubt clearing session. So in case you have any doubts from a particular week, you can transfer the doubts to me. If it is clearable in the session itself with time permits, we can do it in the same session itself, or else we can do it in the next session. So please do note down your doubts whenever you are been taking these sessions. That is, whenever you're watching your videos and you feel that some portion is not comfortable or you're not clear with those things, you can point it out to me and I'll be helping you in these doubt clearing sessions. Also, suppose you are entirely uncomfortable with an entire topic. Suppose if many people feel that one particular topic is not very clear, so then if you request me priorly, I'll be able to discuss those topics also. So these are the session goals, the things that we plan to do. So is whatever we have discussed till now clear to all of you, like why we need these sessions and stuff? Is it clear to both of you, both Anusha and Ragul?
Yes,
Yes,
ma'am.
ma'am.
Yeah. So like I would like to know about like few details about both of you, like what is your background, whether you are doing your PG or UG, and what is your idea of why you want to take up this particular source for. So Anusha, if you can go ahead and tell me your like basic idea about your background and why you're taking this course, it will be helping me in like modulating the questions in such a way. That's why. So Anusha, can you please tell me?
Yeah, sure. I am from CRR College of Engineering. I am
Okay.
studying third year of BTech.
Okay.
Apart from courses, we have 2 credits for NPTEL sessions. So I joined for the fundamentals of electronics as I am electronics and communication student.
Okay. You're in your third year, right?
Yes,
So you'll become, I think you'll already be familiar with these topics.
yes, somehow.
Yeah, okay. So thank you so much, Anisha. So what about Ragul?
I am Rahul from Pondicherry.
Okay,
As a Bharat curriculum, we need to complete 2 courses, so I joined this course. I am studying
okay.
third year currently.
Okay, you are also coming from EC electronics background.
I am from electrical background.
Okay, you're from electrical. In which year you are? Third year.
Third year.
Okay, so both of you are from electrical and electronics background, so I think it will be like easier compared to other students for you both of you to understand the concepts. So what we will be doing is that I'll be displaying the questions. I'll give you some 2 to 3 minutes for each question. So in that meantime, you have to either go through your notes or you have to discuss among both of yourselves. Since only two people are there, we can make it like a discussion way. Both of you can discuss with each other or you can refer your notes, etc. So take your time to think about the answers and then you can tell me the answer, and you can refer any of your notes or any other sources, etc. And if you tell me the answer, you can go on with an explanation as to why you have selected the answer as well. So is that clear? And if that is clear, we can move on with today's question answer sessions.
Yeah, okay.
Okay.
Okay. Okay, so today's first question is, the empirical observation made in 1965 that the number of transistors in an integrated circuit on an IC doubles every 24 months is called dash. A. Ryder's law, B. Moore's law, C. Hyde's law, and D. Gates' law. So please take your time to think, and both of you can tell me the answer.
I think it's B, man.
Okay, and what about Anusha?
I don't know.
You can take your time. Like, if you have your notes, you can go through and just check, or you can use Google or any other source and just read about it so that it becomes a part of your study process. And just take a few like 2 to 3 minutes. You can just Google on and then you can find out like what is Moore's law. Like one person has already mentioned is Moore's law. So both of you can check what is Moore's law. Is it the empirical observation that number of transistors in an IC doubles every 24 months? So can you please check and let me know?
Ma'am, it's Moore's law only. I'm
Okay.
100% informed.
Okay. So Moore's law is the observation that number of transistors in an IC doubles every 24 months. So that is the correct answer. So is it clear for both of you what is Moore's law and what is the observation? It means that whenever you have any device, so in an integrated circuit, we all know that there are transistors. So in every 24 months, what happens is that the number of transistors in the device goes on doubling. That is the rate at which the technology will progress. So is that clear for both of you?
Yes, ma'am.
Yeah. So next question is the nature of chemical bonding in silicon is covalent. So what is the nature of hybridization of the material? Is it is sp, sp2 or sp3 or
Three.
sp4? sp3. So why is it an sp3?
SP3.
Can you tell me what is sp3 hybridization? And it,
When there are four electrons, in order to become stable, they will arrange themselves in such a form that it becomes stable.
yeah.
So
So
here
yeah.
it forms tetrahedral shape, and I forgot that name of the law. They will be showing that shape and hybridization.
Okay, so
Here we have
basically sp3 hybridization is that one 2s orbital and three 2p orbitals combine and form a tetrahedron. That is, they form a hybridized orbital structure. So is that clear? That is the sp3 hybridization. And silicon is a very like when you are going through like through the course of this material, like entire course of electronic materials, you will see that silicon is one of the most important materials that we will be discussing. So that is why here we need to know the hybridization of the silicon material, because we know that in all transistors, IC engine, the most important material you come across is silicon, right? So that is why the hybridization of silicon is sp3. So is it clear to all of you? Like somebody else joined, I think recently. Yeah, some new person has joined, Suraj Kalyan Shetty. So is the question clear to you? First is the empirical observation that the number of transistors in an IC doubles every 24 months. So we had discussed that it is the Moore's law. Next is the chemical bonding in silicon is covalent. We all know that. So what is the nature of hybridization? It is the sp3 hybridization. So far we have discussed only these two questions. So I hope it is clear to the person who has joined recently as well. So please do let me know if you're not understanding any part or you have any difficulty.
Yeah,
Yeah,
understood. Thank you so
yeah,
much.
yeah,
This
sure.
is Suraj.
Suraj, and can you please tell me a little bit about your background and what is the motive of your taking this course?
I am working actually with lamb research. I'm to the semi field,
Okay,
and I just wanted to learn about the field. So I thought taking the course would more add value to me. That's the reason. I
okay,
finished the first one also,
okay, like
fabrication,
fundamental
and
fabrication
yeah,
courses. Yeah,
yeah, and this is the second one I took. Yeah.
okay,
Yeah,
okay,
but one more feedback I wanted to give was the submission dates are very quick. The first
okay.
one is 7th, and the second one also shows 7th. Sometimes it becomes a little bit tedious because we're working and something urgent comes in and you have put two assignments on the same day.
Yeah.
So that,
The thing is that I think we like the contents will be released to you in every week, right?
yeah, I
So
know, but
yeah.
sometimes,
So one
sometimes you're
suggestion I
traveling.
can
I was
give
traveling
is
last week,
yeah, try to
and if you
complete the
can,
assignments in the same week as when the material is released so that it doesn't pile up towards the end.
no,
Yeah,
I know.
please try to do
At
that.
least
Yeah,
give the same time for everything because this also has come now only. We were planning. I was planning to submit the first one on
7th.
7th, first
Yeah,
week of February, and I see the second one also is lined up for
yeah.
same date.
And
So if you
during
can
that
give a
week,
week
again,
gap,
another
right?
submission will come up because your third week material will be released, and along with that, third
Mhm.
assignment will also be released.
That becomes a little hectic when we are
Yeah,
working. I'm okay if if it is planned, okay. But sometimes what happens, there is a travel. I was traveling last week, and so you cannot take the courses, and
okay.
there's some work, and you're sick sometimes. So if you can give a gap of 2 weeks or a 1 week between each assignment, that will help
Okay,
because we
so the
clear
thing
the
is,
first
I
one,
can
and
communicate your need to the
yeah,
team, but I think it is a fixed pattern for usually
sure,
NPTL courses. So anyway, I'll communicate it,
okay,
and in case they are willing to change it, I'll let you know.
sure, thank
Yeah,
you.
thank you so much for the feedback. Yeah. So next is which of the following are not N-type dopants for silicon? So not more than one answer may be correct. So basically we know that in case of silicon, we have both N-type and P-type dopants. So if we are adding a P-type dopant, what happens is the number of holes goes on increasing, and if it goes to an N-type, number of electrons goes on increasing. So based on that, and if you know the periodic table well and good, we will know that group 3 and group 5 is the basis for dividing these into N-type in P-type dopants. So from these options, can you tell me which are not N-type dopants? So please take your time and think and get back to me. Yeah, we have phosphorus, aluminium, bismuth, and gallium. So out of these, which are not N-type dopants, which means that they are looking forward for a P-type dopant. So which out of these is a P-type, or is or R is a P-type dopant? Okay, can anybody tell me which is silicon? What group element is silicon? So based on that, we can find out. So can anybody tell me what is the group number for silicon? Anyone?
14.
No, I'm asking the group. Is it a group 3 element or a group 4 element or a group 5 element?
Not sure, ma'am, but it will come like carbon, silicon, germanium.
Yeah. So can you just any everyone please check and tell me whether silicon is a group 3, group 4, or you can just Google it. Like what are group 4 elements or what are group 3 elements? So based on that, if suppose your element is group 4, say for example silicon is group 4, what happens is that if you're doping with a group 5 element, it becomes an n-type dopant. If you're doping with a group 3 element, it becomes p-type doping. So now if you check what are the group 3 elements, you'll be able to answer this question.
Ma'am, can you repeat once again?
So basically silicon is a group 4 element. Okay. So if you have a group 4 element and you are doping it with a group 5 element, it becomes n-type doping, because we can see that from group 4 to group 5, there is one excess valence electron. So the number of electrons has increased. So when you are doping it with an higher valence electron element, what happens is that it becomes an n-type dopant. Suppose, and we know that silicon is a group 4 element, we are doping with a like group 3, that is lesser than that. We know silicon is 4, we are doping with a group 3 element. It has one less electron in its valence shell. So what happens? The number of holes goes on increasing. So that becomes p-type doping. So now if you check group 3, group 4 and group 5, you will get which are p-type and which are n-type. Is it clear?
Okay, ma'am.
Yeah.
I think phosphorus will come as answer.
Yeah, that is n-type or p-type.
P type.
Can you check once more?
Not sure, ma'am. You can explain.
Okay. Anybody else? Anybody else? P-type and N-type doping. Anybody else has any answer? Can you please check here? Let me try, see if I can find an image to make it clear to you. So is this particular table visible to all of you? This yellow blue table? Yeah. So here if you see, we have silicon as group 4 element. So that is 4, let us say that it is 4 valence electron. Now, if you have a group 5 element, say like phosphorus, arsenic, antimony or bismuth, what happens is that it has 1 electron extra. So if you are adding any of these blue color elements to silicon, what happens is that the number of electrons will increase. So these are n-type dopants. And suppose if you see group 3, we have aluminium, gallium, indium, thallium, etc. So if we add any of these group 3 elements, what happens? It has one less electrons and therefore it will be p-type doping. That is, we will be increasing the number of holes. Is that clear now? So
Yes,
these
ma'am.
are our n-type dopants and these are our p-type dopants. So now if you see Our examples, we have aluminium, bismuth, and gallium. And if you see here, we have aluminium, gallium, and if you go below this, we'll have bismuth. So bismuth is there. So your answer is aluminium and gallium. So is that clear?
Yes, ma'am.
Yeah.
So we need to be thorough with all the concepts of chemistry, ma'am, in this
Not
course.
necessarily, because when you're learning about semiconductor materials, these are like very commonly known things. You need not be only, usually we'll add only these phosphorus, aluminum, bismuth, and gallium to silicon, not more than that. So at least be sure with these four elements. That's all.
Okay, ma'am.
Yeah, you
Because
need
we studied this
long
way
back.
back in
Yeah,
10th
yeah,
standard.
yeah. Yeah, so need not be, but just the common elements. So some common semiconductor materials like silicon, then we have gallium arsenide. So based on some common semiconductor materials, just be briefly aware about those things. You need not memorize the entire periodic table or anything. Yeah. So next question is, in an intrinsic semiconductor, the number of thermally generated electrons in the conduction band is dash the number of holes generated in the valence band. So it is an
Option
intrinsic yeah, equal to. Is that clear? What about Suraj? Is it clear?
Yes, ma'am. Clear.
Yeah. So basically, intrinsic semiconductor means that we are not adding any external elements. It is just because of the temperature that carriers become generated. So when carriers are generated, what happens is that whatever number of electrons are created in the conduction band, the same number of holes will be generated in the valence band as well. But when we go to extrinsic semiconductors, that is not the case. So when what happens is that when we add elements like these, either the electrons or the hole, like not both, only one of these gets changed. That is why those are extrinsic and these are intrinsic semiconductors. Yeah. So next question is, complete the sentence. That is, when n atomic orbitals in a metal overlap, they form n molecular orbitals which have n energy states which can accommodate dash electrons. Is it n by 2, n, 2n, or 4n?
2n.
2n. Yeah. What about
2n.
the other person? Is it clear? Yeah.
Yeah,
The
2n.
answer is correct. Yeah. So whenever we have n atomic orbitals, molecular orbital theory states that they'll form n molecular orbitals and they have n energy state, and in each energy state we can accommodate two electrons of opposite spin.
Yeah.
Yeah. So next question is, the derivation of density of states for an FEG, that is free electron gas model metal, involves calculating the number of available states per unit volume. But each state can accommodate more than one electron. So here we learned that it can accommodate two electrons, right? Name the property of the electron that makes this possible. So which
Spin.
property of, yeah, which property? So electric
Spin.
charge, no. Mass, no. Spin is the answer. The condition is that whenever we are accommodating together, they should be of opposite spin. So is it clear?
Yeah, with this, I wanted to check. So, is there no possibility of putting them with the same spin? That is not possible, right? They
No,
have to
that
be
is
with
not at
opposite.
all possible. It will violate the Pauli's exclusion principle, Hund's
Okay.
rule, and so on and so forth. It violates basic chemistry rules.
Okay.
Yeah,
And this happens naturally, or we
it
have to
happens
take care by
naturally.
fabric?
It happens
Okay.
naturally. So that is the only state in which the material becomes stable to us.
Okay, got
Yeah.
it.
So yeah. So next is, what is the density of states, that is G of E, for a free electron gas metal at an energy of 3 electron volt? You have to give your answers in joule inverse meter power minus 3. So if anybody remembers the equation for G of E, you can tell me, and based on the equation of G of E, you can go on solving. Does anybody remember the equation for G of E? If you don't remember also, please go through
No.
your notes or any Google sources, etc., and you can
What are
let
the
me know.
question, ma'am?
Sorry? Yeah, please take your time to check the equation for G of E. That is the density of states in FEG model.
I'm
So
having
we
that
can.
equation.
Yeah, can you please read out the equation? And if you have the equation, you can start solving as well. And you have to tell me which of these options is your answer, is the answer that you are getting. Both of you can take your time and
Got
solve.
one
Yeah,
doubt regarding this.
yeah, tell me.
Instead of using all these constants, we can see like g of e is directly proportional to square root of energy.
Yeah.
So can we directly use this relation alone?
No, but you can use the relation as a proportionality only when we have to compare two things. Suppose we'll be solving a question like that. So here we have to find out the density of state. Suppose you have to compare the density of state, say at 3 electron volt and 5 electron volt, then we can ignore all the constants. But when you are asked only one particular value, you will have to memorize the values of the values of the constants will be usually given to you in your instructions. So you can use those values and then substitute. And one
Okay.
another, yeah, and one more common practice that you can use for your like shortcut way is that solve the constants together and memorize them as a single value instead of remembering each value separately.
Okay, ma'am.
Yeah.
But equation we have to remember, right? It will
Yeah,
not be given.
equation, it won't probably be given. Suppose 8
Oh,
pi root 2 h cube, all those things, and me power 3 by 2, all those things you can convert into a single value and memorize. And
okay.
then you can just substitute that constant into root of your given value. Yeah, so
Got
can
it.
you please solve this and let me know about the answer? You can fail, like you can expect similar kind of questions in your final examination as well. So if you can go on learning and solving these things now itself, it would help you later. And whenever you are solving, instead of you using your physical calculator, try to use the gate calculator, the virtual calculator, because in your examination, you'll most probably be allowed to use only your virtual calculator.
Yeah.
Yeah,
Yeah, this was an issue last time. I never
yeah,
knew that, and I could
yeah.
not do that on the virtual calculator.
Yeah,
So
because
this is
coming
very
up to
helpful.
speed is a bit difficult with the
Yeah.
virtual calculator. The
Correct.
order is reversed when you have to type in constants and stuff.
Ma'am, you can start solving, ma'am. I'm not familiar with using the calculator.
Okay, no, now you can use the normal calculator and solve. Just substitute all the values and tell me the final answer. Yeah, for this session, try, you can use your physical calculator. Next week onwards, try using the virtual calculator. Yeah, this 2 hours is solely dedicated for your learning. So it's not like you have to complete in a stipulated time or so on. You can take your time and solve. And it doesn't matter if it goes wrong also. It's a tutorial, it's a practice session basically.
So this course will be full of problems, ma'am.
Not necessarily. It will be part problem and part descriptive, logical answers. Yeah, like the ones we are solving today.
Because last time I got very less marks due to fully problems.
Okay. Last time too, there was a tutorial session and we had solved these questions in the tutorial, I think.
Oh, I didn't attend, ma'am.
Yeah,
Sorry.
so it's okay, it's fine. This time, I hope this sessions help.
Okay, ma'am.
Yeah.
Ma'am, I got the numerator, but I can't solve the denominator.
Why? Like where are you getting stuck?
Um, while solving the numerator, I got 5.3 into 10 power minus 44.
Yeah.
But when I put h cube, it's coming like it's showing max. I don't know what mistake I did.
Okay. So is this the same substitution you are using? So this is a cube actually, it's not square, it's cube here. So if you put the same thing, so the thing is you have to convert this electron volt into joules. That is one thing while solving these kinds of questions because your final answer is in joule inverse per meter cube, right? So basically you have to convert this electron volt into joules.
So its SI unit is per joule per meter cube, ma'am.
Yes.
Okay, ma'am.
So here what I've done is here ME is power 3 by 2 and H is power 3. So I'm just converting both of them into power 3 by 2 for ease of calculation. So once you do that and you have converted your 3 electron volt into joules, you'll be able to get the final answer.
Okay, ma'am.
Yeah. So please use, can you just use these substitutions and find out the answer?
No, ma'am. You can go to next question.
Okay. What about the other person?
We'll do that, ma'am. I'm driving now, so
Okay,
I'll just
fine,
share.
fine. Yeah. So this is your final answer. That is J is 7.3 into 10 to the power 46. Yeah. So the answer is 7.3 into 10 to the power 46. Okay.
Okay. Thank you, ma'am.
Yeah. So next question is the resistance of a copper wire is 2 milliohm. If the length of the wire is 10 centimeter and diameter is 1 mm, what is the resistivity? It is a very commonly used equation. We know that resistance is equal to rho into L by A. So here resistivity is, you have to find out resistance is given to you, length is given to you, diameter is given to you. So only thing you have to take care here is one is in milli and one is in centimeter and one is in mm, and the final answer they have asked is in nano ohm meter. So based on that, you have to make the conversions. So can you please try? So resistance is ohm, resistivity is ohm meter. So R is equal to rho into L by A and rho is equal to R into A by L. So this is a copper wire. So based on that, can you use this final equation and just solve it? So this is rho is equal to R into L by A. R is given to you. You can find out A from the dia and length is also given to you.
Ma'am, for area we should use pi r square, ma'am.
Yes.
Ma'am, I did the calculation, but I am not getting the any
Is it
price.
the substitution? 2 into your resistance is 2 milliohms, that is 2 into 10 power minus 3. You have to substitute. Pi r square is pi. Your r is 1 mm, so I have converted it, and zero point 0.5 into 10 power minus 3. And finally, you have your length, that is 10 mm is 10 centimeter is given to you. You are converting it into meter. So basically everything is converted into meter. So yeah,
Okay, ma'am. Okay.
yeah.
I didn't convert diameter into radius, so that's what the
Okay.
mistake. You can go to next question, ma'am.
Yeah, so final answer will be 15.7 into 10 power minus 9 ohm meter. So since it is a 10 power minus 9 from your options, you have nanometer. So 15.7 will be your final answer. Yeah. So next is, what are the probabilities of an electron occupying an energy level of 0.01 electron volt above EF at 300 Kelvin and 500 Kelvin? So probability of an electron, we have an equation, right? So based on that equation, it is given that your electron is occupying the energy level that is 0.01 electron volt above. The EF will be considering it to be energy equal to 0. So basically, what happens is that if you have something like, sorry, yeah. So this is basically our equation. Is it clear? This is the equation, that is 1 by
Yeah.
1 plus e power e minus ef by k into t. Ef, that is your Fermi level energy, we are considering it to be what? 0. If ef is equal to 0, then if you substitute, what will be the answer we'll be getting? That is your difference between the first level and second level is
Ma'am, can you solve this question step by step?
yeah. So basically,
Because in video I didn't understand this part. Staff told like some top band, bottom band, Fermi level. The complete thing is messed up. I didn't understand this sum clearly.
okay. So basically you have what is known as the probability of an electron occupying or not, right? And suppose you have an energy level like this and above you have an energy level like this. Here it is given that the distance between these two values, that is distance between these two values is 0.01. So this is your EF. So this is your EF and this is your energy level E. Sorry, this one is your energy level E. So E minus EF, so the difference is basically 0.01. So is that clear?
Yes, ma'am.
Yeah. So that is the case. So if you have E minus EF is equal to 0.01, then if you substitute all the constants, then how it will be? K is a constant, temperature is given to you. One calculation you have to do at 300 Kelvin and one calculation you have to do at 500 Kelvin. Let them remain as Kelvin itself, no need for converting it into degrees Celsius. So basically F of A is the probability of the electron occupying the orbital or not. Now we know that E minus EF is 0.01. So in that case, what happens? You have to convert this electron volt here also into joule, that is 1.6 into 10 power minus 19. And here we have Kf value, K value is 1.38 into 10 power minus 23 and T is your temperature, that is 300. So we got the value 0.404. That is one value. Now similarly, can you do the calculation at 500 Kelvin? Since we have found out 300 Kelvin and I've shown the values of all constants, can you try the value at 500 Kelvin?
Yes, ma'am. I'll try.
Yeah.
Ma'am, I'm getting point 0.5.
Yeah. So 0.4422 is the answer. So can you check where you have made mistake? Only changes instead of 300, you have to use 500.
Okay, ma'am. Okay, ma'am.
Yeah, so basically it will be 0.4 and 0.44. This is the order. So option C will be the answer. So here also you have to see you have got both answers, but the options are reversed. So yeah, they are asked at 300 Kelvin and 500 Kelvin. So similarly, you'll have to go for the same order. That is 0.41 first, 0.44 later.
Okay, ma'am.
Yeah. So that
Ma'am,
was
similarly, the question explained in third video of week 1.
okay.
Can you explain that question also at the
I
end of
don't have the question right now, so let me check the video and next session I can solve it in class for you.
okay, ma'am.
Yeah, which is the video
Third video,
of week one.
title is statics and solid.
Okay, so third video for of week one.
Yes, ma'am.
Okay, so I'll check that and I'll solve it in the next session. Yeah. So next question is, in a metal at some temperature T, the probability of finding an electron zero point 0.2 electron volt above the Fermi energy is 1% of the probability of finding an electron at Fermi energy. So what is the approximate value of T? Give your answer in Kelvin and use the FEG model. So here first they have asked, first thing is you have to find the probability of zero point 0.2 electron volt. So from here you know that E minus EF, that is 1 plus E power E minus EF by KT. That E minus EF value here is zero point 0.2. That is one case. The another case is E minus EF, that is we already said that Fermi level we are taking as 0. Is that clear? Keep these 2 points in mind. First case is E minus EF is equal to zero point 0.2 and second case is at the Fermi level. So the question is such that in a metal at some temperature T, the F of E of finding zero point 0.2 electron volt above the Fermi level is 1% of the probability of finding electron at Fermi level. So first we have to do is we have to find the probability at Fermi level. So we'll get a value. Then we have to multiply 1% to that. That is 1 by 100 into that value. That value you have to equate to the probability of zero point 0.2 electron volt above the Fermi level. So once more I'll say, first you have to find the probability at EF is equal to 0. You'll get a value. Then you have to multiply 1 by 100 into that value. So through the new value, you have to equate probability at zero point 0.2 electron volt above the Fermi energy. So is the question clear to you?
Yes, ma'am.
Yeah. So can you try solving? So first you have to find out at the Fermi level. So at the Fermi level, what is the probability?
Fermi level, it's 1 by 2, ma'am.
Yeah, 0.5. Yeah.
Yes, ma'am.
Yeah. So 1% of zero point 0.5 is 1 by 100 into zero point 0.5, right?
Yes, ma'am.
Yeah. So that 1 by 100 into zero point 0.5, you have to equate to the probability at zero point 0.2. E minus EF is equal to zero point 0.2 and you have to find out.
Okay, ma'am.
Yeah, so you know that Fermi level is 0.5. 1% of zero point 0.5 is 1 by 100 into zero point 0.5. That value you have to equate to this particular equation and here you have to use E minus EF is equal to zero point 0.2. And then you will get the T value. The T value will give you the temperature. So can you please try? Yeah.
Ma'am, at Fermi level, answer is 5 into 10 power minus 3.
I didn't get you. Temperature you're telling.
Ma'am, I'm saying F of E.
F of E is 0.5. That is because,
0.5, 1% of 0.5 means
yeah, that is true.
5 into 10 power minus 3.
Yeah, then you have to substitute this value. That is, given the probability of finding electron, 0.25 is that value. This value you have to equate to F of E of zero point 0.2. Then you have to find the T value.
There is no shortcut, ma'am.
No, it's basically all substitutions, right? All values are known to you. Only T's you had only T you have to find out. And one more thing is you have to convert this zero point 0.2 into joules. Yeah. Can you please try solving? Please take a few minutes. It doesn't matter if it takes a bit longer time for you to solve. Just try solving it once. It will get help you get confidence while solving for the examination. Because in exams as well as assignments, similar kinds of questions will keep showing up.
Okay, ma'am.
Yeah.
Ma'am, I have to log out at 8 o'clock. So how many questions are there if you can?
This is our 10th question. 5 more questions will be there. So it's okay in case you log out early. The videos as well as these PPT material, etc., will be uploaded in a link, and the link will be shared
Oh,
with you
I can
later.
use it. Sure.
Yeah,
Thank you so much.
yeah. Yeah, for the person who's solving, can you just see if your substitutions are same as that is shown here?
Yes, ma'am.
Yeah.
I need some practice while solving this type of
Yeah,
questions,
sure,
ma'am.
sure. You can take your time. It's fine. Yeah.
Ma'am, it's not like it's taking much time, but I don't know how to solve.
Okay, you are finding it difficult to solve. Yeah, so
Uh,
basically what you have to do is one thing you can do is first you can solve like all these constants.
I
Uh,
solved that, ma'am.
yeah, and then you have e power t, right? E power some
Yes, ma'am.
value. Yeah, if you
E
take
for some value, how to convert that into normal value? I
yeah,
should take
if
anti-log.
yeah, if you take log on both sides, log e power something is equal to that numerator only. That e will be gone.
Yes, ma'am. I know the steps, but
Yeah.
it's taking some time.
Okay, so finally your answer will be 438.070. So once you get the material, please try practicing these kinds of questions.
Sure, ma'am.
Yeah, and try to get the final value because in the examination only options will be given to you, and only if you get the final value you'll be able to mark. For example, here it's 438.070, and if you see the options, it is we got 438, the answer is 440. So the exact value or at least a nearby value we need to get so that we'll be able to mark the answers.
Just show that log calculation, ma'am. E raised to, if you can just show that. E raised
Uh,
to KT, right?
Currently, I don't have the means to show it. The thing is, I don't have my tablet where I can
Okay.
write something and show you. So in next
Okay.
class, I'll do it for sure.
Yeah, probably if you can just put the detailed steps for this, it will help.
Okay, fine, fine. I'll show how to solve it finally.
Yeah.
Yeah.
Thank you. Because that was a problem last time also. E raised to, because that doesn't show in the virtual calculator, log value doesn't come.
Come. Okay, so the only thing you
So
can do is
can
that
you can we substitute E directly? That's also one of the methods, right?
that I don't know. I've never tried that.
Because E also has a
It
value.
has a
So
value,
can
yeah, but
yeah,
let
can
me
we
check
do
if
that?
let me check
That
if
will be
it
more
gives the same
easier to
answer.
calculate in a virtual calculator than
Calculator than
converting
using
everything to
to
log and
log.
everything. Yeah.
Yeah.
If you can give that E value, it will help because last time I was searching and I was not successful. But
Okay,
last time the objective questions were less
fine.
problems, so it was okay.
So next week I'll do one thing. I'll do with both the e
Yeah,
value as
please.
well as the log value.
Thank you.
Yeah, and I can show you how the answer come. Currently, I don't have the means, that's why. So next week, surely I'll
Yeah,
show you
that's
how
fine.
to
That's
solve.
fine. Yeah.
Yeah. So the next question is, what is the dependence of density of states on energy in a three-dimensional solid? So this is like the proportionality you asked before. So if you remember the
Linearly,
equation,
I think.
yeah, it is it linearly or
Parabolic, I think. It's a parabolic in the.
yeah, based on the equation, if you see it is root of EV, right?
Okay.
Yeah, so your
Yes,
second
ma'am.
option will be correct. That is
Square.
density of
Yeah.
states increases as the square root of energy. So
Square.
that is, yeah. So if you see here, it is the square root. So the exact answer you'll be having. Yeah. So next is this is also a proportionality related question. So here the resistivity of two metals A and B are given to you. Two resistors are fabricated from A and B respectively. The length of the resistors are same, but the diameter of the resistor made from A is twice the diameter of the resistor made from B. So what is the ratio of the resistances? You have to find RA by RB. So we know that R is equal to rho into L by A. And you can denote them as RA and RB. So here we have RA is equal to rho A LA by A into RA, or area of A, and similarly for B. And now based on these, the lengths are same. So LA is equal to LB. That is fine. Then we don't know rho A and rho B, right? The resistivity is 16 and 56, and we have to find out Ra by Rb. So based on whatever is given in the question, you'll have to start substituting. First is length is same, so La is equal to Lb. Next is the diameter of the resistor made from A is twice the diameter of resistor made from B. For example, if dB is some x value, dA will be twice. So using that relation, now you'll have to substitute. La is equal to Lb and dA is equal to 2 times dB. And if rho A and rho B are 16 and 56 respectively, can you try solving Ra by Rb? So please do, that is Ra by Rb is equal to this particular fraction by this particular fraction. La is equal to Lb, so basically they'll cancel out. dA is equal to 2 times of dB. So based on that, what will be the ratio? Can you try? It's just a ratio value. It doesn't involve any substitution or anything. Here you have to substitute 16, here you have to substitute 56. That is 16 and 56 nanometers are given to you. So can you try substituting? Rest all will get cancelled. Pi by 4 will go, LA and LB will go. And here it's nano, so that 10 power 9 minus 9 in both numerator and denominator will go. Only thing that will remain is one is the resistivity 16 and 56 and other is the diameter values. Here it will be dA and that will be 2 times of dB. So can you try substituting?
Yes, ma'am.
Yeah.
Ma'am, I have to log off.
Yeah.
Any means to connect to you online?
In the sense,
Any means to connect to you for any questions? If I cannot attend the calls
okay.
for this, and probably I'm missing now also. So if I don't understand anything
You can reach out to
specific,
me
can I
using my
mail you?
mail ID. Yeah, sure. You
Mail
can.
ID?
Yeah,
Okay. There is somewhere written
yeah.
on
Yeah.
the material.
Okay, so let me show you. So this is my mail ID.
Okay, I'll just which one? Okay, Sandra. Okay.
Santhara.pmr@iitm@gmail.com.
Thank you, ma'am. Thank you
Yeah,
so much.
sure.
I have noted this down.
Yeah,
Thank you.
yeah,
Bye bye.
yeah.
Ma'am,
Can
it's 0.414 mm.
yeah. So yeah, 0.07. So where have you gone wrong? Can you just check?
Ma'am, I have problem with mathematics, ma'am.
Okay, so basically what it will come is dB square will get cancelled. So 16 by 4 will be there, divided by 56 also will be there. So something like 4 by 56 will be your final value that you will have to calculate.
Okay, ma'am.
Yeah, you got 0.14 or something, right?
Yes, ma'am.
Yeah. So if you see here, LA and LB will cancel because LA is equal to LB, that is gone. Then pi by 4 will get cancelled. Then we have dA square and dB square. This dA you have to submit as 2 times dB. Since
Ma'am,
it
yes,
is,
ma'am, I got the
yeah,
answer, ma'am.
since it is 4, 16 by 4 is 4 and you have 56 here. So 4 by 56, it's 0.714.
Okay, ma'am.
Yeah. So next is the process of increasing carrier concentration by adding impurities to an intrinsic semiconductor is called?
Doping.
Yeah. So next is at absolute zero temperature, the conduction band of a semiconductor is partially filled, completely empty, or is it unpredictable? At absolute zero, the conduction band. That is, there is no thermal energy present in the system. Yeah.
Hello, ma'am.
Yeah.
It's completely empty.
Yeah, that's the right answer because we know that it is absolute zero temperature and therefore there is no thermal energy available in the system and therefore it will be completely empty. Yeah, and the question is, which of the following is an example of a 3-5 semiconductor? That is, one element will be from group 3, one element will be from group 5. So can you just Google what is group 3 element and what is group 5 element? So you'll get the list of elements. So can you just match and tell me which is a 3-5 semiconductor?
Yes, ma'am.
Yeah.
Option B, ma'am.
Okay, gallium arsenide is the answer. That is one element gallium is from group 3 and arsenide is from group 5. So is that clear?
Yes,
Yeah.
ma'am.
Now one thing you can do is you have your assignment submissions for week 1 and week 2, right?
Yes, ma'am.
Yeah, you can just go through the questions, and in case you have any doubts whether some question is not clear, you can ask, and I can give you some hints on how to solve them.
I have not started it, ma'am.
Okay, so
I was watching all videos.
okay, you need to still complete these. Like you are yet to watch the videos, right?
No, no, ma'am. I have completed watching all the videos, but I didn't start it.
Okay, the assignments you have not started yet. So please go through your assignments, and in case you have any doubts, please do reach out to me using my mail ID.
Okay, ma'am.
Yeah. So is there any other concept that is not clear, like theoretical concepts from the first week that is not clear?
That only, ma'am. The third video
Okay,
problem.
the
I
third
didn't.
problem from third video and how to solve log type questions, right?
Ma'am, not log type questions. It's about finding that n value.
Okay, fine.
Yes, ma'am.
Yeah.
It's about finding number of electrons and holes in a band.
Okay, for the Ni values. Yeah, number of
Yes,
carriers
ma'am.
question.
No, no, ma'am. Its formula is integral of g of e f of e dt.
Okay. So using like in video 3, there is a problem related to that, and you have doubts in solving that.
Yes, ma'am. Using that.
Integration. Okay.
Yes, ma'am.
Okay. So I think I have noted it down, and I think we can discuss that. So I'll give you how detailed video of how to solve those.
Yes, ma'am. One more doubt, ma'am.
Yeah, sure.
If we study this NPTEL topics alone, it's it enough for GATE.
Which subject are you planning to give for GATE? Electronics
Electrical,
and
ma'am.
electrical. Fine, fine. So you're taking different courses for each subject. Is it like that?
I'm not taking each course separately, but first time I'm trying a core subject in NPTEL.
Okay. So the thing with GATE is that you now have to check your weightage because different topics will be having different weightages, right? So if semiconductor is holding a good amount of weightage, like many questions are coming from semiconductor portion, then this will help you. But the thing is, if your GATE electrical exam, it has questions from different syllabus and number of semiconductor questions are very less, then it might not be that effective. So first you have to see previous year questions and see which area most number of questions come from. And if you're very strong in that area, it will help in getting more marks in GATE.
Ma'am,
Yeah.
I'm not asking like that, ma'am. I'm asking like, is this the level of GATE questions? If I prepare for
Okay.
NPTEL, can I answer GATE questions
Yeah, at
also?
least numerical part, it will help you very much. Similar kind of numericals you can expect. And one more thing is that if you're comfortable with solving the using that virtual calculator, that also will be a huge plus point. So numerical part, it can help you very much, I feel.
Okay, ma'am.
Yeah.
Next section, can you teach me how to solve exponential problems? I
Yeah,
have
sure,
problem with
sure.
that.
Yeah, sure. Yeah, yeah. Next, I've noted it down. So next week we'll like manually solve, like step by step, we'll solve how to do an exponential problem. Maybe a few of these questions itself, I can again solve to you step by step.
Yes, ma'am.
Yeah.
I will also refer, but I need some help.
Yeah. In the
That's why I asked.
meantime, whenever you are free, try using the virtual calculator because it's not the same as using the physical calculator. And in both GATE as well as this thing, they'll allow only virtual calculators.
Oh, okay, ma'am. Okay,
Yeah.
ma'am.
In GATE, and you can use the same. It will be, I think it's almost the same calculator for both of these. Even in the NPTEL exam, the virtual calculator they are giving will be same as that one usually given for GATE.
Yes, ma'am. Yes, ma'am. It's same only,
Yeah,
ma'am.
yeah. So is it your first attempt that you're going to give for GATE?
Yes, ma'am. Just now I'm studying third year, ma'am.
Okay, fine, fine. And the thing is, have you checked the semiconductor syllabus where they are completely same or not?
No, ma'am.
Okay.
There's no one to guide me. Now only I came to know about
And
these things.
one more thing is there, other than this course related. Yeah, hello, hello. Yeah, hello. Hello.
Hello.
Yeah, hello. Am I audible?
Yes, ma'am. Yes,
Yeah.
ma'am. Audible.
Yeah. So the thing is,
Yeah, there is something. It just went off.
yeah. So one more thing is, like this course is on electronic materials and devices, and like right. So there is one more course in NPTEL that is Fundamentals of Electronic Device Fabrication. So some part of that course also might help you in answering some gate questions. So that particular question is basically on how to manufacture silicon wafers, what are the processes involved, etc., and all those things. So that is a 4-week course in NPTEL. So in case that, I think it's available without enrolling itself in YouTube. So you can check that out as well. And there is in particular one particular YouTube channel, I'll be putting these videos, whatever we are discussing in these sessions. So for fundamentals of electronic device fabrication, also I've already uploaded some videos. So for questions related to that, you can go through that, I think.
Oh, okay, ma'am.
Yeah,
Okay,
it
ma'am.
is fundamentals of electronic device fabrication.
Mainly, I came to this course because of only placements, ma'am. I have
Okay.
placements in 2 to 3 months.
Okay, fine, fine, fine. Yeah, so since you're from electrical background, you'll get many questions from this, like basic fundamental questions from this area.
Yes, ma'am. Many of my seniors suggested this course. They told to study this electronic devices very thoroughly to get placed in core companies.
Okay, fine, fine. Yeah, so this will like both these courses will help you very much. One thing you can do is like based on the company who's visiting, one thing for all companies, fundamentals need to be strong, like what are semiconductor materials, their properties, how to manufacture them, and then doping. All that there they might not go for equation-based questions and all, but at least logical questions surely you can expect.
Okay, ma'am.
Yeah, and in case it's
Only
some
one topic
company
missing.
focusing on MOSFETs or transistors, etc., later section of this course will be focusing on that area. So you can focus on that as well, like
Yes, ma'am.
device-based questions.
Okay, ma'am.
Yeah.
Microchip is visiting our college, ma'am. Only
Okay.
one company is.
Visiting. Okay, fine, fine, fine. So basically, one thing they can ask is one is maybe fundamentals and other is based on devices, right?
Oh, okay, ma'am.
Yeah.
Ma'am, you got into IIT through JEE or GATE, ma'am?
No, actually, the thing is, I'm pursuing my PhD at IIT. So first, for I cleared GATE and then got into an NIT for MTech, and following that, I joined IIT for my PhD.
Oh, okay, ma'am.
Yeah. So if you're
Many of my friends say that MTech is all waste. That's why I'm asking you.
depends on which college you are in. Suppose you are in IIT or an NIT. In NIT, I won't say that much. In an IIT, getting into MTech means you have a very good chance of getting placed.
Oh, okay, ma'am.
Yeah. And in NITs, if you are coming from maybe like CS, ECIT or electrical background, there are comparatively fairer chances compared to mechanical and civil, etc. But coming to an IIT, if you're interested into research, you can go for MS, and if you're interested in getting placed, you can go for MTech. And for both these, you need to clear GATE. And they'll be having
Oh,
cutoff each year, and based on that cutoff, you'll be called up for interviews or
ma'am,
allotment.
by practicing previous year questions alone, it's it enough, ma'am, for GATE?
For GATE, previous year will help you a lot, but every year GATE exam will be conducted by different institutions, right? So based on that, they can change the pattern, but at least some extent of questions, at least the like whole idea which all areas are important, all those things you will get from previous year question. And one most important thing for GATE is that you should be very good in solving these numericals within a small amount of time. That is the main thing.
Okay, ma'am. Because I have only less than 1 year to attend this exam
Yeah. So
in
focus
coming
on
this year.
the important areas and try solving maximum number of questions from that area.
Okay, ma'am.
Yeah, for example, I
What
came from
about
mechanical background, and some subjects that I studied in BTech, they'll carry only like every year, maybe like only 3 marks or 2 marks will be asked. That area you can skip without any fear. They won't be asked, and even if they ask maximum, they'll ask for 3 or 4 marks. So that's fine. But some areas, minimum
okay,
some 15 to 20 marks, they can ask. So that area we can focus very much.
okay, ma'am.
Yeah.
I thought that this alone was enough.
No, you have to focus on the subject. For the subject I told is I come from mechanical, so there are like subjects like fluid mechanics, solid mechanics, material science, etc. So this material science they'll ask only for 3 marks. So that entire subject you can skip. It's fine.
Oh, okay,
Yeah.
ma'am. I also came through that mechanical syllabus. They told like thermodynamics was most important topic.
Yeah. So thermodynamics, they might be asking from like 10 or 8 to 10 marks from one subject itself you'll debate. Then you'll have to solve maximum number of questions from that. So similarly, based on your previous year electrical papers, identify the important subjects and their areas.
Oh, okay, ma'am.
Yeah,
Okay, ma'am.
and in that area you can keep on solving from YouTube videos or from like previous year question bank will be available from that. And towards nearby your exam, suppose some 1 or 2 months before exam, take up like question solving session from any of those online available things like question solving only.
You are telling about test series, ma'am.
Yeah.
Oh,
So
okay,
what
ma'am.
they'll do is that similar to Gate itself, the same portal will come up and they'll have a timer also within 3 hours. You can, as if a real Gate exam is happening, you can keep practicing. So that will help you in getting up to speed. Solving all these things in 3 hours, that also requires some amount of practice. Yeah.
Okay, ma'am.
So once
But
you're,
only
yeah,
problem is they tell to watch all the NPTEL videos regarding all the subjects, but I don't have that much time. That's why I'm
yeah, that
asking.
is what is. Suppose you're going for a syllabus subject and NPTL sometimes it goes into very depth, too much depth, and that much depth might not be required for Gate. So
Oh, okay, ma'am.
whatever videos you feel are important based on previous year, focus on those videos more. And only if you have extra time, focus on some in-depth videos.
Oh, okay,
Yeah,
ma'am. Okay, ma'am.
suppose some subject you are taking and some 50 or 56 lectures might be there online. It's not like you have to memorize and thoroughly go through all 56. Out of that, maybe some 20 or 25 will be very important. So focus on that first.
So you are basically telling to identify important topics and
Yes,
focus on that only.
yes. And if you have extra time, then go through other things. First and foremost, you identify important topic subjects. Like you will be having some from many subjects in your BTech, right? So based on that, identify the important subjects, and inside the subject, identify important areas.
Okay, ma'am.
Yeah,
Okay, ma'am.
and then maths and general aptitude, everyone has to focus.
Okay, ma'am. Are there any reference book for max and aptitude? Yeah, some good reference book.
I actually went for coaching at ACE, so I don't know whether some reference materials are available or not. I'm not that sure.
Oh, even I also thought of going, ma'am, but it's at Hyderabad only. In South India, we have only at Hyderabad.
Yeah, that's what's and along with your classes, it might be difficult to manage. I think now there might be option of online courses. You can check that. In my time, that online option was not there. But once COVID happened, I think they have online options.
Yes, ma'am. They have online option, but
Yeah,
I'm
time
not ready
management
to
will
that.
be difficult.
No, ma'am. The same thing I did with NEET, and I failed.
Okay, so you parallelly balancing, yeah, it might become an issue. So one thing you can do is that since you're in third year only, you can have two attempts, right? One you can appear now and one you can appear in your fourth year also. So first attempt you
Yes.
focus on these important areas and try and see if that thing is working. And if it's working, you can focus on the same thing.
Oh, okay, ma'am.
Yeah.
Okay, ma'am.
In third year you can appear once, in fourth year also you can appear before you join for your PG, right?
Yes, ma'am.
Yeah.
So that's what I came to ask, ma'am.
Yeah.
Thank you, ma'am.
Yeah, sure. Thank
Ma'am,
you.
another thing, ma'am.
Yeah.
After getting gate marks result is come, they will conduct any interview, ma'am, before
No,
joining
for
the PG.
MTech, I like yeah, at least in my time, they didn't have any interview. Based on your gate marks, you will have to sign up in an allotment portal. In that portal, you have to give your choice of college. So based on your marks, they will do an automatic allotment. That time there was no interview.
Oh, okay, ma'am. Okay,
Yeah,
ma'am.
but if you're doing anything related to research, for example, MS by research or PhD, etc., they have an interview separately.
Oh,
Yeah.
so we can also join a PhD using gate, ma'am.
Yes, if you have a gates valid gate score, direct PhD you can go and you will get 6 years for doing your PhD directly after BTech. You need not go for a PG.
Yes, ma'am. I heard about that.
Yeah.
You also receive some stipend of 25K or 35K
Yes,
monthly.
initially it is some 31, 31, and then it increases to 39. And recently they have revised, it has gone to an increased amount recently. It's 35 initially and 41 later on, I think.
Yes, But they said after PhD you need to do only teaching jobs. There are no jobs at all available.
That depends. So after PhD, you have to identify. Like the thing with PhD is that it becomes very specific. It's not a broad spectrum. You'll be studying only one area. So if you want to get a job after PhD, you'll have to identify the companies working in that area. Suppose you're working on your PhD is on MOSFET, you have to identify companies working exclusively on MOSFETs and then apply there.
Oh,
Yeah,
okay,
the
ma'am.
number of companies you can apply becomes lesser and lesser if you're going for a PhD. That is the main thing.
Yes, ma'am.
Yeah, and you have to identify the area where maximum number of placements are there. Go for a very, suppose nowadays people are focusing on this data science, AI, ML, etc. So scope is increasing. So identify based on that. Take your PhD topic such that you will get a job later.
Yes, ma'am.
Yeah,
Another doubt also, ma'am.
yeah.
I have interest in doing MTech in VLSI field, but if you join VLSI means we need to do ECE in BTech. But
Mm.
I am from electrical background.
But
Can
that
I
won't,
join?
yeah, you that won't be an issue because while selecting for this allotment in MTech, right? So they will give which are suppose you want to join VLSA, they will say which all papers are eligible for. Like, suppose you have gate in mechanical, gate in civil, gate in electrical, they'll say which all gate papers are eligible for applying. So it's not like only EC people can apply. People from different backgrounds can apply.
So while writing exam itself, we should decide that, ma'am.
No, you can just check online. Like suppose you are interested in taking your MTech set, say IIT Madras, you can check online. Suppose IIT Madras VLSI, which all examinations of GATE they will accept. Suppose they are accepting electrical, means no issue. You can go on with electrical itself.
So it will vary with each institution, ma'am.
Yeah, it will vary. It will vary with institution as well as the number of seats also.
Yes, ma'am.
Yeah,
Also, I heard about like IIT Madras is conducting some online course,
for data
like
science. Yeah.
uh, I don't know whether it's data science or not, but like they are saying like you don't need to do BTech from normal small college tier 3 college tier 4 college. You can do from IIT Madras through online itself. It's equivalent to studying in IIT. They say.
Yeah,
Is it
that as far as I know, it has only a BSc course for data science. It's the, for BTech, they are not yet providing any online thing. BSc data science recently they have started, and yeah,
ma'am, I'm asking about BSc, ma'am. Is it real
yeah.
or it's some?
The thing is, the first batch is still going on. They have not yet started their placement, so it's like yeah, the courses are good, but whether they are getting placed or not, we'll have to wait and watch. But still, the certificate will be worth it. Yeah.
We are not at all expecting certificates, ma'am,
Okay.
nowadays.
Okay.
So okay, ma'am. Thank you, ma'am.
Yeah,
Thank you, ma'am.
sure, sure. No problem.
So next week also same
Yeah, same
Monday,
time.
ma'am.
Yeah,
Monday.
Monday 9 to 7. Sorry, 7 to 9. We'll be having the same set of sessions. And in case, try to go through your assignments. And wherever in assignments you have doubts, please note down. So I can give you some. I am not supposed to give you the direct answer. At least I can give you some hints in solving them.
Yes, ma'am. I'll sure solve, ma'am.
Yeah, and yeah, then the next session we'll solve some questions like step by step how to substitute and solve. I'll show you.
Ma'am, can you send any materials for problems for reference?
So these whatever I'm discussing now, I'll be uploading in one drive folder, and the drive will be shared to you. Whatever study materials you require.
Ma'am, no, ma'am. I don't want this PPT, ma'am. I'm asking for books like materials.
Books. The thing is, problem-wise, books getting them would be difficult. Theoretical part you might get, but problems I don't think as directly solved ones you might get. But if you get any gate question bank solved question papers, in that you might get similar questions. That is
Yes,
one way.
ma'am. I'm having Yes Academy previous question papers.
Okay, solved ones or unsolved?
Solved, ma'am.
Solved, huh?
Previous year,
So
last
you
year
can check
we
in
have
that
solved.
whether similar lines of questions are there.
Oh, okay, ma'am. Okay,
Yeah,
ma'am.
yeah. Okay.
So I can ask you doubts, ma'am, in your
Y-
mail ID.
Yeah, yeah, you can ask your doubts. Yeah,
Okay, ma'am. Okay, ma'am. Thank you, ma'am.
yeah. Yeah, thank you so much. So we'll meet next week.
Thank you,
Yeah.
ma'am. Bye.
Bye.